So x, y, and z are integers. So for x squared plus y squared plus z squared minus xy minus xz minus yz is equal to 0, prove that x, y, z is equal to 0. Okay, so what we want to do right there, we cannot use cases like it last time. So what we have to do is to use mathematical manipulation, then produce a factorized form of this, so that we can be able to manipulate this statement and produce and make sure that we prove that x is equal to y is equal to z. So let's see how we can do that. So the first step is to multiply by 2. Okay, so we multiply everything by 2, produce 2x squared plus 2y squared plus 2z squared minus 2xy minus 2xz minus 2yz is equal to 0. So after this is minus. After this, we want to arrange the terms with x and y together. Let's start with x and y. But while doing that, we need to split this 2x squared and 2y squared into x squared and y squared, x squared plus y squared, x squared plus x squared, y squared plus y squared. This is what I mean. If you split this one, you produce x. Let's write the first x right there. It's x, okay, squared. Let's write the first y there. It's plus y squared. Okay, so what we want to find a term that has x and y, which is this 2xy minus 2xy. So for it to be clear, let's put brackets right there. So remember, we are left with 1x and 1y. Okay, so the next thing that we're going to do is to do for yz. Okay, so plus y squared plus z squared minus y 2yz, like this. Okay, plus, okay, I don't know if this space will be enough. We did for xy, we did for yz, we didn't do for xz. So for xz, we will have x squared plus z squared minus 2xz, like this. This is what we will have. Okay. So if you count our x's and y's and z's, remember we have two x's, x squared. We have two x squared right there. So this is the first x squared, and then this is the second x squared. We have two y squared. This is the first y squared. This is the second y squared. We have okay, I think that's we have two z squared. Okay, so this is the first z squared. This is the second z squared. So everything is balanced. These ones were not changed. They are just the same as they were. Here, then here. Okay, so what we are going to do is after doing this, after producing this, we are going to try to factorize this part. Okay, so how would you factorize this part? Is it not x minus y squared? If you factorize this, what do you get? You get x minus y. Let's see, x minus y squared, I think. X squared minus 2xy plus y squared. Yeah, you get this. If you factorize this part, you get this part. Okay, you get x squared, x minus y squared, plus, if you factorize this, y minus z squared, plus what is this? That is x minus z squared, like this. This is what you get. So after getting this is equal to 0, like this. So after getting this, remember we want to prove that x is equal to y is equal to z. Okay. After arriving here, we can say either is this right? Either x minus y is equal to 0, or x squared, sorry, like this, or x minus z squared is equal to 0, or x minus z squared. So this squared was supposed to be out here. So it was something like, it was supposed to be something like this is equal to 0. So from this first statement, I think we can agree that x is equal to y. And then from this, I think we can agree that x is equal to z. From this, I think we can agree that, why did I this was supposed to be, okay, this is supposed to be y. I'm sorry about all these mistakes. This is supposed to be y minus z. Okay, y is equal to z. Therefore, if you look at this, x is equal to y and x is equal to z. So from these two statements, I think we can safely say that x is equal to y and x is equal to, it's also equal to z. From this, x is equal to y, and then the same x is also equal to z. So x is equal to y is equal to z. Hence shown or proved. I don't know what you are going to say. So I think we have proved this statement. So